Okay, I've graphed a function. It's a quadratic function, turns out, by the construction. And I've graphed it in an interval in a window between x equals 12 and x equals 16. And the window goes from y equals 8 up to y equals 24. Now, not familiar with this as explained, but this line is halfway between the top and the bottom. Okay, then this line is halfway between that line and the bottom. This line is halfway between this line and the bottom. So every line is halfway to the bottom from the last line. From that, we can figure out what the y coordinates are. Like this one, this line is halfway between here and here. Well, halfway between 8 and 24 is y equals 16. So there's a line y equals 16. Here's the line halfway between 8 and 16, and that's 12. So this line is y equals 12. Then this line's halfway between 12 and 8. That would be y equals 10. There's 8, there's 10. This line here is supposed to be halfway between 8 and 10. So this would be y equals 9, and so forth. X from 12 to 16, that means this rectangle, this window is 4 units wide. So the line through the center is halfway between 12 and 16 is 14. Halfway between 14 and 16, well, let's look again. Here's the center line. This line is halfway from the right edge to the center. What's halfway from 16 to 14? Well, it's x equals 15. And then halfway from 14 to 15 is x equals 14 and a half. Now, I don't have a good place to label that line down there, and we might not need it, but I'll label that line here. Similarly, this line is x equals 13. And this line, which I'll label up here, is x equals 13 and a half. So we have handy labels so we can make estimates based on this graph. Okay, then I ask, estimate f of 15. Now, of course, I just gave you the boundaries, and you needed to use the geometry of this thing to figure out what the numbers are, because you need to be able to relate to the numbers. F of 15 means a value of y equals f of x when x is 15. That tells you, you just go to the line x equals 15, and you draw a vertical line. So you see all the points where x equals 15. You go up that line until you hit the curve. And when you hit the curve, you're at a point. So you go across here, and you get y equals whatever. Now, if you do it accurately, this point is right on the line, x equals 15 and y equals 12, because of the way this is constructed. The way it looks like this is a little more than 12. Now, if this is 12 and this is 16, then 15 would be here, 14 would be here. So I'm going to say y is approximately 12.4 in this line. So from this estimate, f of 15 is approximately equal to 12.4. And then solutions of y equals f of x equals 14. Well, where is y equals 14? We draw the line y equals 14, halfway between 12 and 16, we get the line y equals 14. And we see that this line intersects the curve in 2 points. Now the solutions are the values of x that make this true. So we want to find the values of x that makes f of x 14. Well, we have the points in the graph where f of x equals 14 because y equals f of x. So we simply project down here. And I'm going to just let that line extend on through the label for x equals 13. But here's 12 and here's 13. That looks like about 12.7. Over here, here's 15 and here's 16. Well, you know, if that looks a whole lot like x equals about 15.3. So our estimates are x equals 12.7, x equals 15.3. So what I'm asking here is nothing except what we did on the first or second day of class. Estimating y for given x, estimate x for given y. Y is your f of x value. You put x, if you want to find f of x, you draw a line for that x value until you hit the curve, and you estimate the y value. So it's just what we've already done. It's just that the language is a little bit different. Okay. Now, then I tell you f of x is 2 times the quantity x minus 14 squared plus 8. What's f of 15? If this is the correct equation. And can you solve the equation f of x equals 14? Well, now we're going to do a little arithmetic. F of 15, well, 15 is your value of x. This is what f of x is. If you know what x is, you just plug x in and you get the value of f of 15. And that's 2 times 15 minus 8, minus 14 squared plus 8, which is 2 times 1 squared plus 8, which is 10. When we estimated this, we got 12. So I must have done something really bad. It's 15. Go over 1 and up 2, over 1 and up 2, I get there. So it's 12. Doesn't seem to agree. Something wrong with my equation. I'm a little mystified. The reason I'm a little mystified is I wrote the equation down wrong. I wrote the equation down as 2 times the quantity x minus 14, and it should be 4 times the quantity x minus 14 squared plus 8. So I gave you a wrong equation there. I was very careless when I wrote that down. Okay, well, that doesn't make much difference. Everything I said is true. The estimates are okay. Now that I'm trying to use that formula, I find that formula is wrong. It should be 4 times this, which is 4 times 1 squared plus 8, which is 12. And we compare that with our estimate y approximately equals 12.4, wasn't it? 12.4. And we find that for a hand sketch graph, that's not bad. We're not off by all that much. Now, f of x equals 14. So f of x equals 14, just to make sure. We've already estimated that it ought to be about 12.7 or 15.3. You can't see that because the board's off the screen. How do we solve this? Well, first we have f of x equals this. So we can say that 4 times x minus 14 squared plus 8 equals 14. Now we solve that equation. Now you've seen in your pre-calculus class at least how to solve that equation. So I'm going to let you take just a minute or two and see what you can do along the lines of solving that equation. One thing is you don't get x squared minus 196. So don't even square this. Just do everything else you can do and try to isolate your x minus 14. Then I'll show you how to square it and how to use a quadratic formula. Okay. Now, what's this say? It says f of x equals 14. It doesn't say anything about f of 14, although we just did f of 15. It might seem kind of natural to do f of 14 when you see that 14 there, but that's not what this says. Y is equal to f of x, so it's y that's equal to 14. Okay. So to solve this, well, we can do the thing that people like to do. We can certainly subtract 8 from both sides. We're trying to isolate x. And I've warned you, you don't want to try to isolate x by squaring this unless you know how to square this. I'm going to show you how to square it in a minute, but you don't square this and square this. The square doesn't distribute over subtraction. Okay, so what we can do is we can get rid of this 8. That's going to make this a little closer to being equal to x. Of course, that gives us 4 times x minus 14 quantity squared plus 8 minus 8 equals 14 minus 8. And I keep telling people, write out this step because Otherwise, you might try to subtract the 8 from the 4, or something even worse possibly. I see all kinds of stuff because people aren't writing out this step, okay? And not understanding that you can't subtract like 8 from 8x and get anything that makes sense. Not sure how many people here are doing that. I haven't seen that, but I have to keep saying that because people simply aren't doing that, and I want to make sure we cover it. Anyhow, okay, so having subtracted the 8 from both sides, as expected, the 8's going to go away because 8 minus 8 is 0. So we end up with 4 times x minus 14 squared equals 6. Okay, now what can we do with it? Well, I'm still telling you, you don't know how to square x minus 14. Many of you don't know how to, most people don't know how to square x minus 14 when they come into this course. Okay. We can divide both sides by 4 though. And there we have perfectly good step. Then the 4 is a factor of the denominator. In fact, it is the denominator. And this 4 is a factor of the numerator. It's something's multiplied by everything else to give you the numerator. So we can divide the 4s and we get x minus 14 squared equals 3/2. Now, this tells us what number x minus 14 has to be. It has to be the square root of 3/2. X minus 14 squared is 3/2, and x minus 14 is the square root of 3/2, or possibly the negative square root of 3/2. Just as if x minus 14 squared was equal to 25, this question is asking, what do you square in order to get 25? That thing is going to be x minus 14. What do you square to get 25? Show me with your fingers. Everybody knows. I've seen you hold those fingers up before, so we've used that exercise before, okay? If this was 5 over here, then, or 25 over here, then x minus 4 squared would be 5 or possibly negative 5, right? So with that reasoning, x minus 14 equals plus or minus the square root of 3/2. And we don't really need parentheses around x minus 14 because we're not squaring it anymore. We're not doing anything else with it. So now we want to add 14. And we get x minus 14 plus 14 equals just get all messed up. It's too bad. Try it again. Okay, get out of the way. So we get x minus 14 plus 14 equals 14 plus square root of 3/2, adding 14 on both sides. So our final solution is x equals 14 plus or minus square root of 3/2. Okay. Well, then you want to figure out what the square root of 3/2 is. And it's about 1.2, maybe 1.23. So that would be 14 plus 1.23 or 14 minus 1.23. At this point, we have an approximate solution. That's what those wavy lines mean. So this gives us 12.77 or 13.23. Now my estimates were 12.7 and not 15, 15.3. Okay, now 14 plus 1/2 is 15.23. Okay, so I'm going to say, okay, well, let's just compare estimates our estimates were pretty close. And they would be if you were to construct this function properly, okay? Make a good graph. All right. Now I notice that nobody did the assigned homework on applications of quadratic functions. I assume that's because either you didn't see it or you weren't able to do it. Since everybody here is pretty good about getting their homework done, I'm just curious, can you kind of look and see if it was really there? Okay, there is more that I wanted to say about this function. This is a pretty easy solution if you just remember that you're looking for x minus 14 squared equals something, and then x minus 14, because if the square equals something, the something is either plus or minus the square root of that other thing. Okay. X minus 14 squared is x minus 14 times x minus 14. And we have this thing called the distributive law, which everybody should be familiar with, at least in their memory at some point. It says, okay, if I multiply x minus 14 by this thing, that means I've got to multiply x by this. I'm going to color code this. Just to make it clearer what I'm doing. X minus 14 multiplied by x minus 14. That's equal to x. X is multiplied by x minus 14. But also minus 14 is multiplied by x minus 14. Does that make sense? That's your basic distributive law. Okay. And that equals what? Well, x multiplied by x minus 14 is x times x. I'll keep the color coding. And then it's minus x times 14. And then it's minus 14 times x. plus 14 times 14. This multiplies this, and this multiplies this. This is a minus 14. When I multiply minus 14 by 14, get the wrong colors here, I get a plus, which is why I put this in different colors, plus. But it's plus, where'd it go? There it is, 14 times 14. So that what's happened is x has multiplied x, there it is. X has multiplied negative 14, there it is. Negative 14 has multiplied x, there it is. And negative 14 is multiplied negative 14, there it is. We do that carefully. And you get x squared minus 14x minus 14x plus 196. And of course, you got minus 14x and minus 14x. That'll give you minus 28x plus 196. So f of x is x minus 14 squared plus 8. X minus 14 squared is this. And there we have it. We add 8. We get this. X squared minus 28x plus 204. Now, f of x equals 14 means x squared minus 28x plus 204 equals 14. We want to use the quadratic formula, but to use a quadratic formula, we've got to have 0 over here. We get x squared minus 28x plus 190 equals 0. Now, I'm going to put 3 dots here. There are 3 dots. You subtract 14 from both sides to get this. So that x equals 28. Plus or minus the square root of the quantity, negative 28 squared, minus 4 times 1 times 190. All divided by 2 times 1. And I really do recommend that you work this out. But we're going to get exactly the same solution because this is exactly the same equation that this was. It's just in different form. It's going to come out 14 plus or minus the square root of 3 over 2. So when you have an equation like this, you have two alternatives. One alternative is these steps. You just subtract 8 from both sides, divide by 4, and take square roots. It's basically a 3-step problem. Or you can make it into a 5-step problem or 6-step problem, whatever. First, you got to square x minus 14, which you got to do carefully. Then you get this equation. Set that equation equal to 14, and then it's just about 3 steps. Okay. So it's more complicated to do this. So this is a nicer form. Also, if you want to find the vertex of the formula of this thing, well, the vertex is at negative b over 2a. B is negative 28. 2a is 2. 28 over 2 is 14. Where's the vertex? It's on the axis of symmetry, which is a line x equals 14. If we just go back to the original picture, okay, it should be very clear that that's the case. And then if we plug in x equals 14, we should get y equals 8. I'm not going to actually do that. I'll just point out that x is 14, this is 197. Well, I'm not going to do the numbers. You can plug in 14 here and find out that you're going to get y equals 8. Okay. This function will equal 8 if x equals 14. It's obvious that this one equals 8. This one equals 8 if x equals 14, because 14 minus 14 is 0. This term goes away, and you're just left with 8. And that agrees with the conditions on the graph. Okay. Now I want to give you a little start on polynomials. Let P of x equal x minus 3 times x plus 5 times x minus 1. We want to find the x-intercepts of this function. Again, two things that you really ought to write out whenever you do a problem like this. The x-intercept occurs when y equals 0, y equals P of x, so P of x equals 0. That's the logic of it. That's the thing people keep forgetting. They get to a test, they get a little nervous, goes out of their mind because they've never written this down. If you've written it down 10 times, you're going to have it when you need it. Okay, so we're going to let P of x equals 0. That's x minus 3 times x plus 5 times x minus 1 equals 0. Now, can anybody with their fingers show me a number that would make this left-hand side 0? 2, well, if x equals, was that 2? Okay, if x equals 2, you got x minus 3, okay, which would be -1. And you got x plus 5, which is 7, and x minus 1, which is 1. So we got -1 times 7 times 1, which gives us -7. That doesn't give us 0. Okay? Try again. X equals 0. Well, if you put in 0, what do you get? You get 0 minus 3 is -3. 0 plus 5 is 5. 0 minus 1 is -1. So it looks to me like you get 15. And hold on to that thought, because that's going to be a good answer to a question I'm going to ask in a minute. Okay? Let's say you let y equal 0. And y is what's supposed to be 0. X isn't 0. Okay? Another number. Okay, let's see. Let's not worry about trying to make the whole thing 0. Let's just pick one of the terms. Either, or one of the factors, this factor, or this factor. Pick one of those factors and tell me what number would make it 0. Okay, that's good. You picked the first factor and gave me the number that made it 0, right? What number would make the second factor 0? What x value would make this 0? Well, I'll answer -5. If x is -5, what's -5 plus 5? It's 0, right? What number would make this one 0? Yeah, if we replace x by 1, we get 0, right? So we could replace 1 by 3. That would make this one 0. We could replace 5. I'm not sure what I just said. I think I said some wrong words. Replace x by 3, and this one's 0. Replace x by -5. This one's 0. Replace x by 1. This one's 0, right? Well, we can't replace all the x's with different numbers. But what do we get if we replace this x by 0? Well, what do we get if we replace all the x's by 0? Write it out. Okay, I just want to take a quick look at what you're writing. Okay, now this is the main thing. But one of the main things you need to know about polynomials. Okay. So if we put x equals 3 in, the equation becomes 3 minus 3 times 3 plus 5 times 3 minus 1 equals 0. Now, I don't know if everybody remembered to write equals 0, but we're doing the whole equation, right? So we want the equal 0 on there, and we want to see if it worked. Well, 3 minus 3 is 0. 3 plus 5 is 8. 3 minus 1 is 2. Does that equal 0? Well, yeah. You multiply 0 by 8, you get 0, and then you multiply that by 2, and you still get 0. And then you can pretty easily see that if x is -5, this is going to be 0. And if any one of these is 0, since they're all multiplied, the whole product is going to be 0, and you're going to have a solution. Okay, so we get all these solutions. Let's try. This equation. Well, we're really short on time, so I'm going to have to just show you. Before I do, I'll write this out. I've got time. If we got a bunch of things multiplied together equal to 0, formally, we can say x minus 3 equals 0, or x plus 5 equals 0, or x minus 1 equals 0. That just says if any one of these is 0, the whole thing is 0. And we solve this. By adding 3 to both sides, subtracting 5 from both sides, or adding 1 to both sides. Okay, up here, we can say 2x plus 4 equals 0. You can kind of see if x equals -2, that's going to give you 0, but we just write it out as an equation. Or x squared plus 5x plus 6 equals 0. So this equation splits into 2 equations, which you can easily solve. You get x equals -2 here, or x equals -2 or -3. Now, that's a quadratic equation. You can solve that. You would get x equals -2 or x equals -3. Now, when I write the solution out, I'm going to say x equals -2, multiplicity 2 because it occurs here and it occurs here. It makes this 0 and it makes this 0, and that's going to be really important. So x equals -2 or x equals -3. -2 is multiplicity 2 because it makes this 0 and it makes this 0. X equals -3 because it makes this 0. You want to keep track of that terminology because it's critical for constructing graphs of polynomials the way we're going to do them.